Hi, hello everyone. Myself Dikshit B. I'm currently studying Sri Venkateshwar College of Engineering, Information Science and Engineering. Introduction to binomial distribution. The binomial distribution is a discrete probability distribution that models a number of successes in a fixed number of independent Bernoulli trials. It is categorized by two parameters: the number of trials n and the probability of success p. The binomial distribution is widely in the various fields, including statistics, genetics, and quality of control. Probability mass function. Probability mass function of the binomial distribution gives the probability of obtaining a specific number of successes in a fixed number of trials. The PMF is given by the formula P of x equals to k equals to C of n comma k p to power of k. Cumulative distribution function. The cumulative distribution function of the binomial distribution gives the probability of obtaining a specific number of successes in a fixed number of trials. The cumulative distribution function is given by the formula P of x is r equal to k equals to sigma I equals to k C of n comma I p power I. Mean and variance. The mean of binomial distribution is given by the formula mu equals to n. P, where mu represents the expected number of successes. The variance of the binomial distribution is given by the formula of sigma square equals to n. Expected value and standard deviation. The expected value of the binomial distribution represents the average number of the successes in a fixed number of trials. It can be calculated by multiplying the number of trials n by probability of successes p. The standard deviation of the binomial distribution measures the speed of the distribution and can be calculated using the formula. And we can see the in this figure calculating standard deviation. S of x equals to root of sigma xi minus x bar whole square by n minus 1, and n where n equals to number of data points and xi equals to each. Example application: coin flipping. Suppose we have a fair coin and we want to find a probability of getting exactly 3 heads in a flips. Using the binomial distribution formula, we have calculated P of x equals to 3 equals to C of 5 comma 3 into 0.5 power 3. And here we can see the table of each toss 1, toss 2, toss 3 probabilities. Example application: quality control. In a quality control, the binomial distribution is used to model the number of defective items in a sample of a certain size. For example, a company may randomly sample 100 items for a production line and wants to estimate the proportion of defective items. By applying the binomial distribution, the company can calculate the probability of the obtaining a specific number of defective items in a sample. P of x equals to n by x n minus x, p of x of 1 minus p power n minus x. Limitations of the binomial distribution. The binomial distribution assumes that the trials are independent and we have the same probability of success. It is not suitable for situations where the probability of success varies across the trials or where the trials are not truly independent. In such cases, the alternative distributions such as negative binomial distribution or the hypergeometric distribution may be more appropriate. Binomial formula. Note the general pattern emerging. If you have only two possible outcomes, call them 1 by 0 or yes or no, or success or failure. In n independent trials, the probability of x success number of trials equals to n, x equals to success of out of n, 1 minus p equals to probability of failure, p equals to probability of success. Binomial distribution versus normal distribution. In a certain situations, the binomial distribution can be approximated by the normal distribution. Using the central limit theorem, the approximation is valid when both np and n of 1 minus p are greater than or equal to 5. The normal distribution approximation allows for easier calculations and provides a good approximation for a large sample. Conclusion. The binomial distribution is a powerful tool for modeling the number of successes in a fixed number of independent trials. It is characterized by the probability of masses functions, cumulative distribution functions, mean and variance. The binomial distribution finds the application in various fields and it is often used to statistical interference and design making. And thank you for watching my video. Please like, share and subscribe.